Hello and welcome to our first video of examples for section 4.2 from our calculus text, where we're trying to identify extreme values of functions on, in this case, closed intervals. But the first thing we want to do is we want to get a little practice on finding critical numbers. So from the first more explanatory video from this section, we remember that critical points are numbers for which the derivative is either 0 or undefined. So let's go ahead and start looking at some examples. I'm using the word critical number, critical point interchangeably here. So our first example is a polynomial, g of x equals x cubed plus 3x squared minus 45x plus 20. So let's go ahead and just calculate the derivative of this polynomial. 3x squared plus 6x minus 45. And so we're going to want to solve g prime equals 0 in this case because the polynomial is defined everywhere. One thing I notice is that all of the coefficients in this polynomial are multiples of 3, so I'm going to pull 3 out. And I notice that this polynomial factors as x plus 5 times x minus 3. So I know that I don't get anything from this. A constant can never be equal to 0. So I've got x plus 5 equals 0, x minus 3 equals 0, and so the critical points for this function are x equals negative 5 and 3. Our next example is a quotient, so we're going to need to use the quotient rule. The derivative of the top is 1, so I get x squared plus 1 minus x times the derivative of the bottom, which is 2x, all over x squared plus 1 squared. So I'll look at that numerator and combine like terms. So I get minus x squared plus 1 over x squared plus 1 quantity squared. Now the denominator is never 0. X squared plus 1 is always bigger than or equal to 1. And so for critical points, I'm going to just set the numerator equal to 0. Remember, a fraction is equal to 0 when its numerator is equal to 0. So I get minus x squared plus 1 equals 0. I've got a couple of ways I can go about this. I could multiply through by negative 1, and then I recognize that this factors as x plus 1 times x minus 1. This might be a little bit safer than setting x squared equal to 1, because a lot of times I know students will forget about the negative square root that's involved. And so I get x equals negative 1 and x equals 1. And so those are my critical points here. My last example for just finding critical points is a product, so we could use the product rule. F of x is x times natural log of x. So the derivative of the first is 1 times the second plus the first times the derivative of the second, which is 1 over x. And so that's going to simplify to natural log of x plus 1. And so this is defined for all x bigger than 0. So we will solve f prime equal to 0. So this is good practice from stuff that we saw back in chapter 1 toward the beginning of the course. I can subtract 1 from both sides, and then I can treat each of the sides of this equation as exponents whose base is e. So I get e to the natural log of x equals e to the negative 1. E to the natural log of x simplifies as just x. And so my critical point is 1 over e. And I'll just note that the 3 decimal places, this is about 0.368, so it's a little bit more than one third. So our critical point in this case, there's just 1, x equals 1 over e.